Hello students, we'll continue the chapter Aldehydes, Ketones and Carboxylic acids. I was discussing about aldehydes and ketones. In that we have already completed the nomenclature of aldehydes and ketones, common system and UPAC system. Then the second one is methods of preparation. We have discussed the common methods of preparation of aldehydes and ketones and special methods of aldehydes and ketones. And in the last class we were dealing with the chemical properties of aldehydes and ketones. As I have told, there are many different types of reactions which aldehydes and ketones undergo, as they are very reactive compounds because of the carbonyl group. So we have discussed nucleophilic addition reactions. We have studied the addition of hydrogen cyanide, the addition of sodium bisulfite. We have discussed about the addition of Grignard reagent. We have discussed about the addition of alcohols to the aldehydes and ketones. Okay, so now we'll continue with the next category, that is nucleophilic addition reactions followed by elimination of water. This also comes in the nucleophilic addition reaction, but one additional step is there. But after the attack of nucleophile, there is a intermediate formation, and after the loss of water we get our final stable compound. So that I am categorizing into the second type, that is nucleophilic addition reactions followed by elimination of water molecule. And third is reduction, fourth one is oxidation, fifth is reactions due to alpha hydrogen atom, and the last one is miscellaneous reactions or other reactions. So we will discuss the remaining reactions in today's class. So nucleophilic addition reactions followed by elimination of water. So aldehydes and ketones reacts with ammonia and its derivatives. Ammonia is represented as NH3 and its one of the hydrogen is replaced by some groups. Okay, that is considered as ammonia derivative. So which undergoes a nucleophilic addition reaction, and it gives an intermediate tetrahedral addition product which on dehydration results in the formation of the compound of the form this particular formula. So aldehydes and ketones reacts with, for example, if I consider an aldehyde group or a ketonic group or a compound it may be an aldehyde or a ketone, when it is treated with ammonia or its derivative. If it is ammonia, Z will be H. Okay, so if it is ammonia, Z will be H. If any other groups are there like OH, NH2 or the benzene ring, so if any groups are there, then it is considered as a derivative of ammonia. So aldehydes and ketones reacts with ammonia and its derivatives. It undergoes nucleophilic addition reaction. The nucleophile is ammonia or its derivative. As nitrogen carries lone pair of electron, it acts as a nucleophile, and this carbonyl carbon is electron deficient. So it attacks the carbonyl carbon and there is a formation of a new bond between carbon and nitrogen. Single bond is formed. It's forming the tetrahedral addition product which is represented like this. Okay, so this is the tetrahedral addition product formed. Now this is subjected for dehydration, that is loss of water takes place. The loss of water in presence of acid takes place. Acid catalyzed dehydration takes place. So when water is eliminated, see here, so if you represent it like this, if water is eliminated, there is a formation of carbon double bond nitrogen. Carbon will be only having 3 bonds, so one electron, the remaining valency is satisfied with the nitrogen, so there is a formation of double bond with the nitrogen, and Z, that group will be retained with the nitrogen. So this is the derivative formed as a final product. A stable compound is formed, and this is a reversible reaction. The whole reaction, this is reversible reaction which is catalyzed by the acidic condition. Okay, so we have to maintain the pH, then only we get the required product of this formula. Otherwise we get different compounds as a product. So here remember, aldehydes and ketones reacts with ammonia and its derivatives or its derivatives, undergoes nucleophilic addition reaction to give a tetrahedral intermediate addition product. Tetrahedral addition product is formed which on dehydration results in the formation of the compounds having the formula C double bond N Z, and here Z may be an alkyl group It may be hydrogen alkyl group, or it may be an aryl group, or it may be OH, or it may be NH2, or it may be phenyl, the C6H5NH2 group, NH group. It may be C6H5NH or NHCO, NH2, etc. So like this, Z may be any of these groups which are replacing hydrogen of ammonia and forming the derivatives, and they are acting as a nucleophile, attacks the carbonyl carbon to give the compound. Okay, so we'll see the examples how the addition takes place by ammonia and their derivatives, and what are the products formed by the reaction now. So now we'll see the examples, addition of ammonia and its derivatives. So if I consider the carbonyl group or the carbonyl compounds, it may be an aldehyde or a ketone. When it is treated with ammonia or its derivative, there is a formation of the compounds which are represented by the formula C double bond N Z, and there is a loss of water, right? This I have told. Okay, now you can easily represent, or you can easily remember this by thinking that, see, I am just rewriting it, NH2Z. So there is a loss of water. Okay, H2O is eliminated, so there is a formation of carbon double bond nitrogen and Z. So like this you can remember it. This is not the mechanism, it is just to remember easily. Okay, so a reaction takes place in many steps. Just to remember, I am writing it like this. You can easily write the final compound. So if I take one example, I'll take here. If I consider Z is H, so that will be the ammonia. So what happens when aldehydes and ketones reacts with ammonia? See here, carbonyl compound, when it is treated with NH3. Okay, so what you are getting as a product? See, as I said, here Z is H. I can write it like this also, right? NH2H. Okay, so what happens? There is a loss of water and double bond is formed with nitrogen, right? So what I can write? The formed product is NH. So here we have H in place of Z. So the product is having formula C double bond N H. Here we will be having R or R dash. Here it may be same or different, or it may be hydrogen if it is aldehyde. So depends which group is present, whether it is aldehyde or a ketone. So respective compound you are getting, but this group will be common in, or whether it is aldehyde or a ketone. So what is the name of this compound? So when aldehydes and ketones reacts with ammonia, there is a formation of imine. This compound is known as imines. So imines are formed when aldehydes and ketones are treated with ammonia. Okay, remember this. This is first one. Second one, if I take an alkyl group or an aryl group, okay, if it is not hydrogen, if it is R, it may be an alkyl group or the aryl group, then what happens? As I said, there is a loss of water molecule. So remove H2O and connect the nitrogen with the double A bonded carbon. So what you get? C double bond N R. Okay, so this is a substituted imine. Substituted imines are usually called as Schiff's bases. Schiff reagent anta heltave. So it is forming a substituted imine. We are getting here substituted imine as a product, which are usually used as a Schiff's base. Okay, this is second reaction. Now the third reaction is carbonyl compounds on reaction with hydroxylamine. Hydroxylamine is having formula NH2OH. Okay, so this is hydroxylamine. Hydroxylamine. So when aldehydes and ketones reacts with hydroxylamine, what you are getting as a product? And remember one thing, all these reactions are acid catalyzed. Okay, all are acid catalyzed reactions. Okay, now hydroxylamine. So what you are getting as a product? See, in place of Z what we have? OH. So the product is C double bond N OH. Okay, so we are getting here oxime as a product. The compounds which are having this particular group, C double bond NOH, these are called as oximes. This you have already studied in the glucose. There we have done this particular reaction to check the presence of carbonyl group in the glucose molecule. We have treated that glucose with the hydroxylamine, so there is a formation of oxime which shows the presence of carbonyl group in the glucose, right? So the carbonyl compounds, aldehydes and ketones reacts with hydroxylamine, gives oxime as a product. Okay, then the fourth one is carbonyl compounds on reaction with hydrazine. Hydrazine is NH2 hydrazine. Okay, so in place of Z what we have? NH2 group. So this is also acid catalyzed. So what you are getting as a product? See, in place of Z we have NH2. So in place of Z we can write NH2 directly, or you can remember, I can write it like this one, NH2. I'll rewrite it, NH2. So there is a loss of water. H2O is eliminated. So carbon is doubly bonded with the nitrogen, and nitrogen further links with NH2 group. So we are getting the compounds of the formula C double bond N NH2. Here this carbon is further connected with alkyl group, aryl group, or with the hydrogen, or on both the sides will be having alkyl group. So depends upon the reactant. So the product is here hydrazone. The products are called as hydrazones. It is called as hydrazone. Understood? Aldehydes and ketones reacts with hydrazine to form respective hydrazone. With the loss of water, in all these cases there is a loss of water. Remember that, okay? In all the cases there is a loss of water. Hydrazone is formed. Aldehydes and ketones reacts with hydrazine, gives hydrazone. Clear? We'll write the remaining reactions now. First I'll revise this again. I'll repeat it again. So carbonyl compounds reacts with the aldehydes and ketones reacts with ammonia in presence of an acid, results in the formation of respective imine. Aldehydes and ketones reacts with substituted amines, results, or amines, these are nothing but the amines, okay, RNH2 amines, gives substituted imines. Carbonyl aldehydes and ketones reacts with hydroxylamine to give oxime. Aldehydes and ketones reacts with hydrazine, it forms hydrazone. Okay, remember. Next reaction is fifth one, that is reaction with phenylhydrazine. Aldehydes and ketones reacts with phenylhydrazine. Phenylhydrazine is represented as, in place of Z we have NHC6H5. NHC6H5. This is phenylhydrazine. Phenylhydrazine. Okay, so phenylhydrazine can also be written like this: NH2 NH. C6H5 is nothing but the benzene ring. Okay, so this is phenylhydrazine. So aldehydes and ketones reacts with, I'll write the same reaction now. Aldehydes and ketones reacts with phenylhydrazine in presence of an acid, results in the formation of phenylhydrazones. Okay, respective phenylhydrazones are formed. So there is a loss of water, H2O is eliminated, so carbon doubly bonds with the nitrogen, and the remaining compound groups you can write as it is. So this is phenylhydrazone. Phenylhydrazone. Understood? Aldehydes and ketones reacts with phenylhydrazine, results in the formation of phenylhydrazone. The next one is aldehydes and ketones reacts with 2,4-DNP. This is very, very important for your, mainly for your practical examination. This test is there. Okay, carbonyl compounds or aldehydes and ketones reacts with 2,4-DNP. 2,4-DNP full form is 2,4-dinitrophenyl 2,4-dinitrophenylhydrazine. 2,4-dinitrophenylhydrazine. So this is the full form of 2,4-DNP. So what is the structure of 2,4-dinitrophenylhydrazine then? 2,4-dinitrophenylhydrazine is represented as phenylhydrazine is this one. Okay, NH2, NH, C6H5. So 2,4-dinitrophenyl means we have two substitutions nitro groups. Two nitro groups are present at second and the fourth position. So you can write the structure of 2,4-DNP like this. This is the phenylhydrazine. Right? This is our phenylhydrazine. This is the substitution to the benzene ring. Consider it as a first position. So second position is this one, where we have a one nitro group, and fourth position is this one with respect to this group. First, second, third, fourth. So 2,4-dinitrophenylhydrazine. Okay, 2,4-dinitrophenylhydrazine. So this is the compound. When it is treated with aldehydes and ketones, what you are getting? So there is a loss of water molecule, as I said. It is undergoes dehydration. So H2O is eliminated. So there is a formation of the compound C double bond N, NH. You are getting the remaining groups as it is. Okay, so like this you can write 2,4-dinitrophenylhydrazine. Aldehydes and ketones reacts with 2,4-dinitrophenylhydrazine to give 2,4-dinitrophenylhydrazone. Okay, so aldehydes and ketones reacts with 2,4-DNP, that is 2,4-dinitrophenylhydrazine, to give 2,4-dinitrophenylhydrazone, which will be a orange crystalline precipitate formed in the particular reaction. Okay, remember these structures. 2,4-DNP, the reagent molecular for the structural formula, and the product on the reaction with aldehydes and ketones. So remember, aldehydes and ketones reacts with 2,4-dinitrophenylhydrazine to give 2,4-dinitrophenylhydrazone. You can write it as 2,4-dinitrophenylhydrazone. Okay. Now the last reaction is reaction of aldehydes and ketones with a SemiCarboside. SemiCarboside is represented as NH2, NH, CONH2. Okay, so this in place of Z we have NH-CONH2 group. So when aldehydes and ketones reacts with SemiCarboside, this is called as SemiCarboside. So when it is treated with SemiCarboside, there is a formation of semicarbazole. So aldehydes and ketones react with semicarbazide to give semicarbazone as a product. So just we have to remove this H2O and connect the nitrogen with the carbon atom. So what you are getting as a product, I'll write here C double bond N, NH, CO, NH2. Okay, you can even elaborate the CONH2 as CO, C double bond O, NH2. Okay, so this is semicarbazone. The product formed is called as semicarbazone. So aldehydes and ketones reacts with semicarboside, results in the formation of respective semicarbazone. So this is the reaction of carbonyl compounds with the aldehydes and ketones with the ammonia and its derivatives. It undergoes nucleophilic addition reaction, results in the formation of tetrahedral intermediate, which on dehydration results in the formation of the compounds of the formula C double bond N, Z. Okay, where Z are different groups, and we have studied what are those different groups and how we are naming it. Okay, so I'll repeat again. Aldehydes and ketones reacts with ammonia, results in the formation of imines. which are represented as NH. It reacts with amines, results in the formation of substituted imines, represented as NR. Reacts with hydroxyl amine NH2OH, gives oxime. Reacts with hydrazine to give hydrazone. Reacts with phenylhydrazine to give phenylhydrazone. Reacts with 2,4-dinitrophenylhydrazine to give 2,4-dinitrophenylhydrazone. Reacts with SemiCarboside to give SemiCarbazone. So these are the reactions which you have studied now. Okay, remember these reactions, it's very important. The next category of reaction is reduction. In that, the first one is reduction to alcohols. So aldehydes and ketones undergoes reduction to form primary and secondary alcohols. So here I can write the examples. So aldehydes, if I take an example of an aldehyde, this on reduction is addition of hydrogen. So this on reduction results in the formation of primary alcohols are CH2OH. So aldehydes undergo reduction to form primary alcohols, whereas ketones, represented by RCOR-, so ketones undergoes reduction to form secondary alcohols, which results in the formation of secondary alcohols RCHR-OH. So secondary alcohols. So aldehydes on reduction gives primary alcohols, ketones on reduction gives secondary alcohols. And here we can use the reducing agents like sodium borohydride, lithium aluminium hydride, or we can do the catalytic hydrogenation, that is hydrogen in presence of nickel or platinum or palladium catalyst. So we can use these three as the reducing agents: sodium borohydride, lithium aluminium hydride, and hydrogenation in presence of nickel, platinum or palladium catalyst. Any one of them can be used as a reducing agent for the reduction of aldehydes to the primary alcohols and ketones to the secondary alcohols. I'll write one example here. If I take here CH3CHO, okay, so acetaldehyde I'll take. This on reaction with lithium aluminium hydride results in the formation of ethanol, CH3CH2OH. H2 is inserted, hydrogen is added, so we are getting here ethanol as a product. It is a primary alcohol. Similarly, if I take a ketone like propanone, if I take CH3COCH3, if I take, and if it is treated with lithium aluminium hydride or sodium borohydride or hydrogenation in presence of the catalyst, anything you can use. So it results in the formation of a secondary alcohol, propane 2-ol is formed as a product. So this is how the reduction takes place. So this is the first reaction of reduction, that is reduction to alcohols. Next reduction reaction is reduction to hydrocarbons. Okay, so reduction to hydrocarbons means here we are reducing carbonyl compounds or the carbonyl group to CH2 group. Okay, so then it will be considered as a hydrocarbon. In turn, we are getting nothing but the alkanes. Okay, so here there are two reactions, two important reactions, named reactions are there. One is Clemens reduction, that is Clemens reduction. Clemens reduction is the first one, and another one is Wolff-Kishner reduction. Both are very important for the examination. Clemens reduction, first one. So what happens in Clemens reductions? Here the carbonyl compounds or the aldehydes and ketones are treated with zinc amalgam. It is treated with zinc amalgam. It is represented as ZnHg. It is a alloy of a zinc and mercury. It is called as zinc amalgam, which is treated with aldehydes and ketones in presence of concentrated HCl, hydrochloric acid. So carbonyl compound or CO group is reduced to CH2. So this is called as Clemens reduction. Aldehydes and ketones are treated with zinc amalgam in concentrated hydrochloric acid to give respective hydrocarbon. This is called as Clemens reduction. For example, if I consider here CH3COH, if I take acetaldehyde, if it is treated with zinc amalgam in concentrated HCl, what I'll get as a product here, CO group is converted to CH2. O tagdu H2 ಹಾಕ್ಬೇಕು ಅದರಲ್ಲಿ. So if I remove O and place there H2, what you'll get as a product? I'll get here as the product formed here is CH3. Okay. So if similarly, if I take a ketone, the same reagent if I use, so what happens? You have to remove O and place there H2. So product will be CH3, CH2, CH3. So you are getting propane as a product. So aldehydes and ketones on reaction with zinc amalgam in concentrated hydrochloric acid results in the formation of respective alkanes. Okay, their carbonyl group is reduced to CH2 group. Okay, so this is very, very important for the examination, Clemens reduction. The second reaction in reduction to hydrocarbons is Wolff-Kishner reduction. Here, this is also important, named reaction. So what happens? Aldehydes and ketones are first treated with hydrazine. Hydrazine is represented as NH2NH2. So when it is treated with hydrazine, what we are getting? We are getting hydrazone as a product. By the elimination of water, we are getting hydrazone as a stable product. So this is formed. So this hydrazone formed is further treated with potassium hydroxide or sodium hydroxide, and it is heated. It is heated with potassium hydroxide or sodium hydroxide in a high boiling solvent like ethylene glycol. It is heated with KOH in ethylene glycol. It is heated with ethylene glycol. So there is a formation of the CO group is reduced to CH2 with the loss of dinitrogen gas. So this happens in the Wolff-Kishner reduction. I repeat, aldehydes and ketones reacts with hydrazine. By the dehydration, we get a stable hydrazone as a product, which on further heating with potassium or sodium hydroxide in a high boiling solvent like ethylene glycol results in the formation of respective hydrocarbon. The reduction takes place and there is a formation of hydrocarbon. Okay, so if I consider here CH3, CHO, acetaldehyde, if I take, if this is treated with hydrazine, after dehydration, what I get here? I'll get a hydrazone, which is represented like this: CH3, CH double bond, En, NH2. So this is formed. This on further heating with KOH and ethylene glycol. Ethylene glycol is nothing but ethane 1,2-diol, ethylene glycol. So on reaction gives ethane. So how ethane is formed? See here, this N2 goes out and these two hydrogens connects here. So there is a formation of CH3. So this is nothing but ethane. Acetaldehyde or ethanol on Wolff-Kishner reduction results in the formation of ethane. So this is very, very important for the examination, Wolff-Kishner reduction. Okay. Then fourth category of reaction which aldehydes and ketones undergoes is oxidation. here aldehydes and ketones are having different reactivity towards oxidation. Aldehydes undergo oxidation very easily. Aldehydes are written as RCHO. So this undergoes oxidation very easily to form a carboxylic acid. So this is very easy. Whereas ketones are not undergoing oxidation so easily. Okay, that is because of the presence of hydrogen atom in case of aldehydes. As only hydrogen atom is present to the carbonyl carbon with the one alkyl group or aryl group. So there is no cleavage of any bond. Directly oxygen can insert and there is a formation of carboxylic acid. So not only with the strong oxidizing agent, even with a mild oxidizing agent, oxidation of aldehydes takes place to the carboxylic acid. But ketones will not undergo oxidation so easily. They are undergoing oxidation only in presence of strong oxidizing agents, and that also results in the formation of carboxylic acid. But the difference is, in case of aldehyde, the number of carbon atoms in the reactant and in the product will remain same. Number of carbon atoms in the aldehyde and the resulting carboxylic acid will be same. Whereas in case of ketones, the number of carbon atoms in the product, the carboxylic acid, and in the ketone will be different. For example, if I take one example of a ketone here. So if this is the ketone, this on oxidation results in the formation of mixture of carboxylic acid, as there involves the cleavage of the bonds. Okay, there is a cleavage of the bonds takes place, because of which the oxidation takes place to form different gives a mixture of carboxylic acid with the different number of carbon atoms in the product. So if there is a cleavage of carbon, so first and the second carbon, if I consider these as 1, 2, 3 carbon atoms, if the cleavage takes place here between first one and the second carbon, so I'll write here. So if there is a cleavage of C1 and C2 carbon, if I consider this as first and second carbon, if this cleavage takes place, then it gives a mixture of carboxylic acids which are represented like this. So RCOOH and R-CH2COH. This will be the mixture of carboxylic acid by the cleavage of C1-C2 linkage. If the oxidation takes place in this manner, that is, if there is a cleavage of C2 and C3 bond, this bond is cleaved, then there is a formation of the product like RCH2COOH plus R-COOH. So like this we get the mixture of carboxylic acid as a product by the cleavage of these bonds. So aldehydes are undergoing oxidation easily to form carboxylic acid with the same number of carbon atoms as that of the aldehydes. In mild oxidizing agents also it undergoes oxidation. Whereas ketones undergo oxidation only in presence of strong oxidizing agents to give carboxylic acids, but the number of carbon atoms in the carboxylic acids will be different from the respective ketone. Okay, we'll see some examples here. If I take an example of an acetaldehyde, again simple one. If this is treated with potassium dichromate in acidic medium, which is an oxidizing agent, so what you are getting as a product, acetic acid will be the product formed. Okay, in mild oxidizing agent also we get the same product. Okay, carboxylic acid, number of carbon atoms will be same. Here also we have 2 carbons, here also we have 2 carbon atoms. If I take here a ketone, if this is subjected for oxidation in presence of same potassium dichromate in acidic medium, as it requires a strong oxidizing agent, I'll take the same one. So what happens, what product we are getting here? Here the cleavage of the bonds takes place. So I'll be getting either this bond you cleave or this one, you will get the same product. So you'll be getting CH3COOH and HCOOH as a product. That is, I'll get a mixture of acetic acid and formic acid, and here further this formic acid is undergoing oxidation, results in the formation of carbon dioxide and dihydrogen gases released. So this is possible in case of ketones. This on oxidation results in the formation of mixture of acetic acid and formic acid. The formic acid further on heating results in the formation of carbon dioxide and water. Okay, so like this the reaction takes place. If I take here another example of pentane 2-ol. See, this is pentane 3-ol. If this is the compound, this on oxidation gives mixture of products. So how mixture of products is formed? See, as it is a symmetrical one, either you can cleave here or cleave here, you'll get same compound. Okay, no problem. If it is unsymmetrical, then you will get the mixture of compounds. So if this is subjected for oxidation, what we'll get as a product? We'll get here CH3, CH2, COOH and CH3, COOH as a product. That is propionic acid and acetic acid, propanoic acid and ethanoic acid as a product. So these two compounds are formed as a product on the oxidation of pentane 3-ol. Okay, so the cleavage takes place here. So as it is symmetrical, you will get two products. If it is unsymmetrical, then we'll be getting 4 different carboxylic acid as a product. So understood this one? This is the oxidation of aldehydes and ketones. Here we can use oxidizing agents like acidified potassium dichromate, alkaline KMNO4 and concentrated nitric acid. And even aldehydes undergoes oxidation in mild oxidizing agents like Tollens reagent and Phenylhydrazine solution. That we'll discuss now. Now let us see the oxidation of aldehydes in mild reagents. So mild reagents used are Tollens reagent and Phenylhydrazine solution, as I said, and these two tests are mainly used to distinguish aldehydes from ketones. Only aldehydes are giving this particular test. So when aldehydes are treated with Tollens reagent, you have to take aldehyde, a little amount of aldehyde in one test tube and add Tollens reagent, freshly prepared Tollens reagent, and just warm it, and you are getting a silver mirror or a black precipitate, and that shows the presence of aldehyde. A compound, if on treatment with Tollens reagent, if it gives a silver mirror or a black precipitate, that shows the presence of aldehyde. Okay, so here what is Tollens reagent? It is an ammonical silver nitrate solution. It's a ammonical silver nitrate solution, and AgNO3 and NH3. So that mixture is considered as, that is taken as a Tollens reagent, which reacts to form a complex that will be reacting with an aldehyde. Aldehydes on warming with Tollens reagent. Tollens reagent is an ammonical silver nitrate solution. On warming with ammonical silver nitrate solution, there is a formation of a silver mirror or a black precipitate. Here the reaction is given like this: an aldehyde on reaction with Tollens reagent in the alkaline medium results in the formation of a silver mirror, or a silver mirror or silver is deposited inside the test tube. That is called as silver mirror. So Ag is precipitated, it is deposited, and here the oxidizing agent used is Tollens reagent. Tollens reagent is an oxidizing agent used. So it oxidizes aldehyde to the carboxylate ion. So this is the oxidation of aldehyde to the carboxylate ion. So this is the first test. The second test which aldehydes are showing is, only aldehydes are showing, is Phenylhydrazine test. In Phenylhydrazine test, we are treating aldehydes with a Phenylhydrazine solution. There are two solutions which are considered as Phenylhydrazine solution, that is Phenylhydrazine A and Phenylhydrazine B solution. Phenylhydrazine A solution and Phenylhydrazine B solution. These two are taken in an equal amount before the test. Okay, so what is this phenylene A solution? It's an aqueous copper sulfate solution. And phenylene B solution is an alkaline sodium potassium tartarate solution. Alkaline sodium potassium tartarate solution. So these two are mixed tartarate solution. These two solutions are mixed in equal amount before the test. On taking these two in equal amount, these two are taken in equal amount and it is heated with the aldehyde. So on heating, what you are observing is you are getting a reddish brown color precipitate. So that shows the presence of an aldehyde. Okay, any compound, if you treat it with a phenylene solution which contains these two in equal amount, if you get their red brown precipitate, that shows the presence of that aldehyde in the test tube. Okay, so here what happens in the reaction is, whatever the aldehyde you have taken, that is treated with this copper A and the phenylene A and phenylene B solution. Phenylene A solution will be having copper ions and phenylene B solution will be having an alkaline. It is in the alkaline medium. It will be having excess of hydroxyl ions. This is oxidizing the aldehyde group to the carboxylate ion, and you are getting copper oxide as a reddish brown precipitate. Whatever the reddish brown PPT is formed, it is because of the formation of Cu2O. So this is how the reaction takes place. So this is only shown by the aldehydes, not by the ketones. So tolerance test and phenylene test are the two distinguishing tests for aldehydes, which distinguishes them from ketones. Okay, only aldehydes are giving these tests, as these two are mild oxidizing agents. Only aldehydes undergo oxidation to form carboxylate ions. So these two are very, very important for your practical examinations. In Viva, they'll ask these questions. Oxidation only, we have one more reaction, that is oxidation of methyl ketones by haloform reaction. Here, aldehydes and ketones which are having at least one CH3 group attached to the carbonyl group are oxidized by sodium hypohalides to form sodium salt of carboxylic acid, which are having one carbon atom less than the carbonyl compound taken as a reactant. For example, if I take here RCOCH3, this is the aldehyde or a ketone which contains one CH3 group. It should contain one CH3 group linked to the carbonyl group. So it may, here R may be H or the alkyl group, or so it may be hydrogen or a alkyl group. It may be aldehyde or a ketone, but on other side you should have CH3 group. So such compounds are undergoing this particular reaction where it is treated with sodium hypohalide. Sodium hypohalide is represented by NaOX. So on reaction with sodium hypohalides, there is a formation of sodium salt of carboxylic acid. Okay, so sodium salt of carboxylic acid is formed. Here the CH3 group, methyl group, is converted to haloform. The methyl group is converted to haloform. Here X may be, it may be chlorine, bromine or iodine. Okay, for example, if I take here CH3, COCH3, or if I take here C2H5COCH3, if I take here C2H5COCH3, this on reaction with sodium hypochlorite. Okay, there is a formation of C2H5COONA, that is sodium propanoate is formed, which further there is a formation of haloform. Here I have taken chlorine, so there is a formation of chloroform. Chloroform is having formula CHCl3. If instead of Cl, if I take here Br, I will be getting bromoform. If it is iodine, I will be getting iodoform, CHI3. So, for example, C, if this is the case, C double bond C, if I have here this type of compound, COCH3. So our CH3 is here, methyl ketone is here. So if this is treated with sodium hypochlorite, then only this part is subjected for change. The remaining things remains as it is. The rest of the things remains as it is. So I can write it as COONA. Only this part is subjected for change or the oxidation. It oxidizes to sodium salt of carboxylic acid. Okay, and this CH3 is now converted to chloroform. So this is how the haloform reaction takes place. So this is about the oxidation reaction. In today's class, we have discussed about the reactions of ammonia with aldehydes and ketones and its derivatives, where nucleophilic addition takes place by the elimination of water, followed by elimination of water, and important names of the products formed. And we have studied reduction reaction, where two named reactions we have seen, Clemens Reduction and Wolff-Kishner reduction. Then we have studied the oxidation reaction. Two important tests we have seen, tolerance test and failing test, and the haloform reaction in the oxidation. So these are the reactions for today's class. We'll continue the remaining reactions in the next class. Thank you.